Hello, everyone, and welcome to the public space. First, there is hope. Then there is, cope. And after that, there is ropes. And we are talking today with Bill Gaede. How are you doing, Bill Gaede?
Wear a mask.
Oh, so you wonder if there are social distancing rules here on the public space? We got this social distancing going pretty early before the coronavirus. I only interact with people through screens.
I see. Okay, that's good. Keep your distance.
So today we are talking about space and your vision of space with the rope theory in particular. Space, it may be one of the things that you most convince me of. It is, and I'm not fully convinced of the rope theory itself, but it is this idea that the way physics approaches space is bizarre and unnatural, and in fact, we assume space in our theories.
Yeah, the issue is that, mathematical physics treats space like a physical object. One Nobel Prize winner said the space of essentially mathematical physics is an ether, but we don't call it that because it's taboo. It is an ether. The ether, the space of mathematical physics is made of particles, and it's also used to do gravity. So it's treated as a physical object at all times. And the problem with the particle one is, assuming space is made out of particles, what contours each particle? That's the question you got to answer. If you can't answer that question, it doesn't matter what you say about, your space. You got to answer that question before you begin your theory. And they don't do that.
And that's where you come in and say you base your physics in having objects are things that have a volume that occupy a space.
No. That I want to make sure, because that's an important definition. It's got to be precise, and it can't be wishy-washy. The normal definition that people have in their minds, or the notion that people have of what a thing is, what something is, what an object is see and touch. People say, everyday stuff people can see and touch. And so they say, well, what is an object? Well, it's whatever I can see and touch. I can touch the vase on the table, the chair. We can see all these things. We say that's an object. That's not an object for the purposes of physics. We can't use those definitions. And that's the definition we've used now for 2,000 years. And I'm challenging that definition. I'm saying the definition of something, of a thing, of an object, of a body, is not that which you can see or touch. An object is that which has shape. Okay, and this is an important definition. Let me tell you why. Because it goes to a lot of people, when they come across the rope model, they say, well, how come we can't see the ropes? How come I can't touch the ropes? How is it that the ropes can go through each other? How is it that they don't get tangled? Those are the questions people ask immediately. And the answer is, the first answer, there's more than one answer, but the first answer is, an object is not that which you can see or touch. So you cannot use the see-touch criteria to analyze this issue. The issue, you have to start by defining the word object or thing or something as that which has shape. It has shape. That does not mean you can see or touch it. We can't see the air. Does that mean that there's nothing there? We have all these atoms floating around our eyes, in fact, hitting against our eyes. That's nothing. All these atoms are nothing. No, there's something. We can't see them. And that doesn't mean that they're not something. That's different than space. Space does not have any of the properties that matter has, that atoms have, that things have. And space, can't see it, you can't touch it. But more importantly, space, otherwise known as nothing, is that which doesn't have shape. So now we have two definitions that we can use, because they've never defined the word nothing. We have two definitions, the word something and the word nothing. They're opposite, they're antonyms. Something, that which has shape; Nothing, that which doesn't have shape. Now we can use these words consistently, rationally, scientifically.
Small arrows sent to Lawrence Krauss here. Now, how do you define the word shape?
There's a couple of answers on that, and so I'll go with the first one. We do not need to define the word shape. That's the first answer, and let me tell you why. What we're looking at is criteria to define the word object for the purposes of physics. Until today, until the rational scientific method came along, everybody has defined the word object as see, touch. They use the tangible, visible criteria. We're saying that we don't need those two criteria. Those two criteria are irrational. They're irrational because to see and touch, you need a second object to begin with. Someone has to do the seeing and the touching. The moon is not an object until the asteroid hits it. It has to touch it. Otherwise, neither one is an object. So we have an irrational definition. We can't use that. So what's the issue? The issue is we have to compare the two criteria or the two criterions. We have, on the one hand, shape, and on the other one, we have see, touch. And the question is, which one do we select for the purposes of physics? And here the issue is, what is shape? No, we all know what shape is. If you want to know what shape is, you go to the kindergarten, right? And you show them this, okay? You show them a cube and you show them a ball, and you ask the children, you say, assuming they're of the same material, same color, same everything, you say, what is the difference between these two objects? And they'll say, it's a shape. That's what they'll tell you, because the kid can tell you what shape is. So we know the difference between shape, touch, and see. Hopefully we understand those differences.
Well,
so
I will point out that to make your case, you have invoked a young child looking at the freaking shape, and so you have introduced a subjective element to it. I mean, are you serious, Bill? You have a whole theory of the universe, and you don't have a definition of shape?
Because we don't need it. We only need to know the difference between shape and motion, between shape and touch, between shape and see, between shape and volume, between shape and mass. All we need to know is the difference. And right now we can't get out of the room until we define the word. There's 8 billion people in this conference room, and no one can get out until we define the word object for the purposes of physics. We can't just continue and say, well, what is shape? And then you say, well, shape is this. Well, what do you mean by the word the or the word and? We can go on forever. That's not science. We don't need to define every word in the dictionary to do science. All we need to know is the difference between the criteria, between shape and touch. Right now we have touch. Does that mean that if I can't define shape, for example, right? If I can't define shape, then we stay with touch?
Well, you're talking about semantics around but I mean, this is a fundamental aspect of your theory. Shape is the definition of your physics. You really don't have, are you saying you don't want to define it here on the show, or are you saying you don't have a definition at all?
I have a definition, but I'm not going to use it. I'm not going to get into, it's like I don't need math to do physics. So I'm not going to get into the road of mathematics, and I'm not going to get into the road of defining every word in the dictionary just to please the extreme skeptic. Okay,
well,
that's not science. Science is, all we need to do for physics is know the difference between shape and touch, because right now we have touch and we have see, and those are invalid criteria. That's the issue. So when we ask for the definition of shape and insist on that, we're going out of alignment. We're losing track of the issue. The issue is that if we don't use shape, we have to use see and touch. That's the issue.
It seems to me that this refusal to define it boils down to the fact that any definition you could come up with would presuppose some kind of coordinate system. Shape is a volumetric qualitative. It is something that needs space. Whether you like it or not, when you invoke the shape, you invoke volume and space.
Yes. No, volume not. You invoke space. Volume not. Volume is a mathematical concept that means displacement. We don't displace space when we put an object into space like we displace water when we put a fish into the water. So people have that concept wrong. Volume is a dynamic concept. Space is not. Space is nothing. Space is that which doesn't have shape. But yes, you're right. The word object is a concept. Concept is a word that includes two objects or two words treated as object. In this case, we have the word nothing and the word something. Whatever has shape is the something, and what doesn't have shape is the nothing. That's what it is. But that doesn't mean that we need to define the word shape. Why do you think we need the word shape? Tell me, justify
because
it.
You're the one who comes on my show and says that your entire physics is based around this. I would like to know what we're talking about, because I can leave on this.
We're talking about objects, not about shape. We're talking about objects.
Okay, well, objects, the only way I can tell that they are objects is both because there's a space linking us. In other words, they are sending signal to my eyes, and because I have a brain to perceive these objects.
No, wrong again. Even if God destroys all of humanity tomorrow morning, which he soon will probably, what remains behind are objects. We don't need an observer in science. We kill all observers.
All right. That being said, these objects will be sending light rays in whatever is currently referred to as space by scientists, and what must be accounted for by something defined. That is just my critique, but let's leave it on the side. As a reminder to our crowd, join us on Entropy if you have questions for me or Bill tonight. It's my favorite platform for super chats, and the survey question tonight is, do you accept the rope hypothesis? Let's see if people are convinced. So Bill, where do we start?
Well, let's start at the rope. A lot of people don't really have a grasp of what the theory says, especially the hypothesis. We distinguish hypothesis from theory. Theory is an explanation. Hypothesis is an assumption. And the important part here is the assumption. What assumptions we make about the universe, and also about what science is. And for that, we start with what I call it the golden principle. And the golden principle of physics. You need to have objects to do physics. You can't do physics without objects. If you wipe all objects, all matter from the universe, what is happening? What is going on? So you need to have objects. And objects, that which has shape, not that which you can touch or see. So we don't need observers. And the question is, are we visualizing particles, the whole universe made of particles like mathematical physics proposes? I'm saying that I'm giving a different proposal. And again, I'm not here to twist arms. I'm here for people to understand it. Then they can reach their own conclusions. And we start with saying that all that exists out there, all that's out there is a single thread, closed loop thread. Yeah, that's the single closed loop thread. And I'm saying the black part, forget about the red part, okay? But the black part is space, and the single thread is all of matter. That thread, if you go to the second little picture there, number 2, that thread turns into, twines around itself and turns into all the matter in the universe. It turns into atoms, and so we have all these atoms that they're all essentially made by this thread. Okay, and what continues from one atom to another is the same thread in a twined manner. Okay, and you'll see that in the next one, I think. No, okay, well, they're all interconnected. Okay, all the atoms are interconnected, and that connection there, that's going to be what I call the electromagnetic rope. Light is going to consist of a signal, a torsion going from one atom to another along that rope. That's what light is according to the rope model, okay? And you can see the difference with mathematical physics. They're all discrete particles, and the question is, how does a particle influence another one? And that's why they have to introduce concepts such as mass, field, and energy, whereas, here you have a physical model where one atom can influence another one through the electromagnetic rope, through the signals that go from one atom to another along the rope. That's one. And the other one is you have the force of pull, something that you can't get on the left side. How do you pull with a particle on the left side? On the right side, it's very simple to produce pull because you have a physical connection. On the left side, you can't produce pull. And what's mathematical physics is missing today is the force of pull. They never had a force of pull. And so they explain pull through push. What they say is that they always do it through pressure. Remove what's between the two objects and the particles from the outside, push them in. So they don't have the force of pull. They have a force of push to produce pull. There's no other way because they can't produce pull with particles.
I was wondering, the single thread. Oh, go ahead.
Yeah.
The single thread aspect of your theory, is it necessary? Because it could be that atoms are separated and that the thread is not continuous. We could think of a universe made up of 6 threads or 100 billion threads. Is it what does it bring more to think of it as a single thread?
Okay, the way I look at it, how I ended up with, I didn't start with a single thread. I started with a rope. I tried to figure out what light is. And I said, eventually I came to the idea that atoms are connected, physically connected, and light consists of a torsion along the rope that interconnects any two atoms. But then the question was, you follow that one step further and say, well, hold it. Because if you look at the next few little pictures there, you'll see the construction of the atom. And when you look at the construction of the atom, you see no end. If you look at the, what is it, number 4, I think it is.
All right, let's have a look at this.
Let's look at number 4. Let's look at the construction of the atom. Is this the one?
Oops, number 4 is not playing.
Oh.
Let's try maybe. This one is playing.
Oh, okay. That one. That's the one I wanted. Okay, that one. This is the construction of the atom. What you see is the electric thread, arbitrarily called electric just to keep with convention, goes through the center of the atom, okay? The magnetic thread coils around, forms an encapsulating membrane we call the electron shell, and every atom in the universe provides electric and magnetic threads to our atom. That's how the atom is constructed, okay? So if you look at it, this is a big picture of it. You can see the rope ends at the border, at the red line there, and that's the electron shell, okay? And after that, I think you got to start it. Yeah, you got to start it again. So the rope ends at the atom, okay? It forks out at the boundary there, which is the electron shell. One thread continues straight to the center of the atom. The other one coils around and forms the encapsulating electron shell. That's the model, okay? But then if you look at this, you say, well, where does it end? And the answer that I came up with, unless there's someone smarter than me that figures it out, but I'm saying it doesn't end. We have a single thread in the entire universe. It builds every atom and everything in existence.
All right, very interesting. Now, if you want this straight line which goes nowhere to not end and come back in a single thread, there must be a whole pack of ropes around the universe where the ropes curve back and do a U-turn and come back into the universe. Is that it?
No, remember, the rope is always straight. The rope never bends. The only thing that bends are the threads when they form magnetism. That's a separate issue. But other than that, the rope is always straight. It goes from one atom to another. And so all atoms are built by these two threads, and all atoms release. In other words, out of the other end, you have a rope coming out, and that goes to another atom. And that's in every direction. It's radial. So when you look at that picture, you have to conclude, I don't know, again, unless someone comes up with a better model, I have to conclude that there's a single thread. It's a closed loop thread, and not what you just suggested, 6 different threads.
All right. We have a couple of interventions from the crowd. Oflameo says, Bill, it is Oflameo from your Patreon. You didn't grade my Extinction 101 homework on air yet. Let me submit my explanation again on the next super chat. And he says, all of the entities in question simply don't remember to eat and starve to death because they need food to live. It is a different mechanism to yours because the value of money and the amount of food is irrelevant. I don't know what that refers to.
Okay, that refers to, for 20 years, I've been talking about extinction theory. I'm saying we're the last humans on Earth, okay? Here it all ends. And I've been saying this before the virus just came around. This just highlighted to many people, because we rehash the issue again about the extinction of man. And I'm saying we're the last generation of humans on Earth. Why? Because the global economy is going to collapse. When that happens, not if, but when it happens, when the global economy collapses, money will be no more. And when money is no more, no one has any incentive, any pecuniary incentive to produce food or distribute it to the cities. Most people will die of starvation, cannibalism, the whole works.
Except those like me who have a greenhouse.
No, because again, people think about that. They say, look, I got a garden. The issue will be defense. The Amish produce lots of food. They're great people in producing food, but no one's going to protect them. There will be no 911. The whole thing collapses. And so the problem will be defense. No one will be back to the upper Paleolithic, where everyone's your enemy, even the clan across the street, across the river.
Right. And the guy was mentioning the entities in question simply don't remember to eat and starve to death because they need food to live. I think he's saying that he believes that the extinction will come through food, not so much through money.
Well, it will come from food, no doubt about it. I don't disagree with that, but it's going to come through money, because we produce food thanks to money. If money disappears, let's just assume that, right? If God comes with his magic wand, waves it around, and makes money disappear, right? How do we live now? How do we, we have this chain going around where, we pay for things. And like I was showing my son today, here I have a 20 euro bill, right?
Wow.
And it turns out that you go to the store, right? And it's incredible. It's almost surrealistic. You give this piece of paper and they give you a bag of potatoes. And you say, hold it, what did I give him? I gave him a piece of paper. That's how crazy our system is.
Yes. Well, I think that you're buying a lot into the modern illusion. It's clear that everyone relying on money, that is a very efficient system for now. And if it crashes all of a sudden, yes, there are problems. But in the end, people can also exchange, people can do dealings. Of course, it would hurt a lot if money was to disappear, but humanity can survive.
The issue is that when money disappears, in other words, when I say money disappears, what disappears is exchange. That's the issue. There will be no trading. Hunter-gatherers, the upper Paleolithic, they did not trade. They had to hunt their own food directly. And I cannot imagine a bunch of Neanderthals, just sitting around the campfire and waiting for the middleman to say, look, I'm going to hunt for you a mammoth, and I'll bring it over, and you pay me with rocks, the seashells, whatever, and I'll give you the mammoth. No way. And so we're going to be Neanderthals in an asphalt jungle when that happens. And there's going to be no trade, because the only thing of value will be food.
All right. Boot on Face sends a super chat. He says, does Bill think COVID-19 unemployment is recoverable?
That's a big question. It's a good question. I've been thinking about that a lot lately. I don't know if this is the start of what I said, 20 years ago, that the economy is going to collapse. And I'm not saying this is the collapse, but I'm saying this could be the start of that collapse. It could be several months, maybe a few years, maybe weeks, for all I know. I mean, I don't know. I don't have a crystal ball to tell you. But my gut feeling is that this is the start of that final phase, which is where the global economy fails. Because you got now, for example, in the United States, #1 country in the world as far as economics is concerned. And a lot of countries can cling on to the United States and need the United States. So it's the center of the empire, right? And if the United States collapses, got 40 million people out of work right now, 20% of its workforce, that's going to have an effect over China and over Europe, Japan, the important countries out there. And what's going to happen is the Chinese are going to have some unemployment because they won't be able to sell to the United States, and so on and so forth. And that could be the start of a domino effect where one country falls right after another.
All right. And Lawrence Forbes says, I usually watch the program for politics, not science. So you may have discussed this before. Has gravity ever really been proven? Some non-mainstream scientists say it's bullshit. Thoughts from both of you, please. Starting with Bill.
Well, first of all, in science, we don't prove. Proof has to do with religion. Proof, evidence, all those words belong to religion. In science, we don't prove. In science, we explain objectively a mechanism so that you understand it. The decision that you make at your home saying, well, I believe in this theory, or I don't believe in that other theory, that's your personal opinion. That's your religion. But in science, we don't prove. So that's number one. The second one is that gravity, I explain it, and I'm explaining it with ropes. I'm saying that all atoms are interconnected. So as an object, for example, let's say an astronaut, right? He's falling to Earth, free fall. No parachute, no nothing, right? He's just falling to Earth. As he falls, every atom in his body is tied to every atom on Earth by these ropes, okay? Now, the ropes are not elastic. They're not rubber bands. They don't stretch. They don't shrink, okay? And so what happens, they're under tension. Every rope from one atom to another is under tension. It's always straight, okay? But as the astronaut falls to Earth, the ropes fan out, okay? I don't know if you see my hands here. Let's see if I can. Okay,
like the sides of Earth.
So that's going to be the acceleration of gravity, because more and more what I call effective ropes are tied to the astronaut. Far away, all the ropes come together. Close by, the ropes fan out, and that's the acceleration of gravity. If you understand that, now you understood the mechanism of gravity. Whether you believe it or not, whether you believe there are ropes out there, well, that's your personal opinion. That's religion.
All right. Oflameo says, Bill, you say no trading. I say no eating. My explanation is unique from yours and just as good as yours. Give me an A+ on my Extinction 101 homework.
Okay, well, we'll have to analyze that in more detail. I'm saying, yes, we will die of hunger, starvation. That's going to be the main point. There's going to be cannibalism. Who knows what's going to be out there? Maybe they even throw the nuclear weapons at each other at the last moment. That's also, there was infighting among the T-Rexes at the last moment as well. You know, Sue, the dinosaur, the T-Rex in Chicago, has 2 bite marks from another T-Rex and survived. So apparently, they had some infighting. So that could happen as well. But I think what's going to trigger it is going to be money. Why? Because our entire global economy depends on money. We're all used to money. But it turns out that money is not money. If I go to your store and I say, look, I want to buy that hat that you've got there on sale. Okay. And I come up and pull out of my pocket and give you some Vietnamese money. Will you accept it? And you say, well, hold it. I'm not going to accept that. Well, hold it. It's money. It's backed by the government of Vietnam. Well, what do you mean you won't accept it? So money is not money. You know, we got to keep that in mind. Okay.
All right. Let's get started again on the rope theory. So you have this graph, which illustrates a proton star, you call it?
Yeah, I call it the proton star because it looks like a star, like a sea urchin, pointing in every direction. So you can give it any name, any type of analogy that you want. But the point is, think of it as a star. It's a 3-dimensional star, okay? And you have all these electric threads. And electric, again, a lot of people ask me about that, the nomenclature. It's just to keep with convention. It's got, you could call it the magnetic thread. You can just call it the thread, whatever. They're all the same thread. But the point is that all these threads from every atom in the universe converges on our atom in the center of the atom. And the so-called magnetic thread, again, just for the sake of nomenclatures, nothing more than that, coils around and encapsulates the proton star. Now, a lot of people ask because, Ernest Rutherford, 1919, he proved so-called proved, again, the problem with the word proof. He said an atom is mostly empty space. And the reason he came up with that is he ran his gold foil test where he bombarded it with particles. And some of the particles came back, meaning there was a center where it hit an atom, the center of the atom, but some of them went through. Most of them went through, in fact. And so he said, well, if most of them went through, it's an atom is mostly empty space. Well, that was a wrong conclusion. And let me tell you why. Because an object is not that which you can see or touch. An atom is that, or an object is that which has shape. The atom has shape. And we have all these, the proton star in there, but you're not supposed to touch it or see it. You're only supposed to have shape. And the proton has shape. It looks like a star, but it doesn't have the property of touch. So you can send another atom right through all those threads that are converging upon the center, and they're not gonna, they're not gonna scrape. They're not gonna bounce back. Not because it's empty space, but because an object is not that which you can see or touch. An object is that which has shape, and that's why.
So you explain. You're saying that these threads here are not necessarily collisionable with objects that you throw at it.
Correct. You cannot collide against them because those threads do not have the property of see and touch that we have in our three-dimensional world. And that's what people have a lot of problem grasping their brains around that. And again, you have to make an assumption because you have to remember one thing. Yeah, those are the definitions. You have to remember one thing, JF, that there are objects such as, the air, the gases, a lot of the gases, we can't see them. And does that mean that they're not objects? They're not made of atoms? Of course they're made out of atoms. You have to make that assumption. They're not made of empty space simply because you can't see it. Okay. And so the definitions are important. You, at least in order to understand what the other person is trying to convey to you, you need definitions. And these people don't have definitions. That's the problem. They get away with murder because they say, oh, space. What is space? Well, space is nothing. And then they start bending space, they're twirling it around, they're warping it and say, oh, that's gravity. What do you mean the warpage of space is gravity? They're saying that, the Earth doesn't fly out of the solar system because there's a curved wall of space, of time, a curved wall of time, a concept that prevents the Earth from flying out. And you'll see it, which one is it? I think it's number 12. Look at number 12.
Oops,
and this is Brian Greene explaining gravity to you. If you look at number 12, hopefully it comes out.
Was it a YouTube video you sent me?
Yeah, one of those. Number
it's
12.
Called Gravity?
Yeah, that one there. Look at that.
The ball travels along an indentation.
He puts the ball in the pool table, right? The bowling ball. And now, how is he going to explain gravity? He's going to say that the moon goes around. Okay, well, it stopped there. Goes around the Earth. Why? Because there's an indentation in space-time. So he's warping space, he's warping time, and he's saying that's the reason the moon doesn't fly out of the solar system. And that we got a problem with that because he's bending concepts.
He's bending time, he's bending space, definitely.
No, he's also bending time. He makes it clear that he's warping time. And how do you warp time? Again, this is a physical interpretation. And then the next thing they tell you, mathematical physicists, is they'll say, well, you're not supposed to take the analogy literally. That's an irrational answer. The guy, I have to explain why the Earth doesn't fly out of the solar system. And if he explains to me and says, look, the physical interpretation that we derive from our equations is that the Earth falls into this depression created by the sun, then what they're saying is that there is a wall of space, of time, that comes up against the skin of the Earth and prevents the Earth from flying out. That's what they're saying. They can't later on say, well, that's just an analogy. You're not supposed to take it literally. That's an irrational answer.
I don't know. I've never heard this analogy defense. I think that modern physicists stand for the idea that space bends, that essentially relativity is true.
Well, yeah, I know that because they do it with coordinates, which are mathematical. It's not even coordinates; they're number lines, but they call them coordinates. They call them dimensions. They're number lines, and what they're saying, they can locate an event, a point in space-time within space-time. They can say, look, we now can describe. We can say that this point here, from a certain reference frame, can be located with 4 coordinates. That's what they're saying. That's different than saying, what is the physical interpretation for why the Earth doesn't fly out of the solar system? And they say time is warped, space is warped. That's what they're saying. So that doesn't make any sense, because that's not, you can't say that love is warped and that's why the Earth doesn't fly out of the solar system, because information is warped. What does that mean? What can that possibly mean?
All right, moving on. Where does that get us in terms of the rope theory?
Well, again, the rope starts by constructing the atom and saying, well, if that's what matter is, if all these atoms form what we call matter out there, the solid stuff that's floating around there, what is space? What is space in relation to that? And you can't turn space into a physical object like mathematical physicists do, because what is the definition of an object, of something, of a thing? It's that which has shape. And if space is an object, if you call it an object, then it's got to have shape. And that means that something is outside of space providing shape to space, like you just said a little earlier ago. An object has to have shape. And if space is an object and it has shape, there's got to be something encapsulating space. And then the question is, well, what is that something? And is that also encapsulated by another something? I mean, what are we talking about? The 4th dimension enclosed by the 5th dimension enclosed by the 6th dimension? Where does it end? At some point, you got to define the word nothing. You got to say, look, what is nothing? Nothing is that which doesn't have shape. And now we can use that, those definitions consistently, because we can say, okay, here we have the thread. It turns into all these atoms. We have all these atoms. What are they floating in? Well, we can't say in space, because space is not a container. It's not a physical object. The atoms float with respect to other atoms, not with respect to space.
Would you say, though, that your theory of ropes involves 3 orthogonal dimensions where the ropes can exist and be distant from each other?
The ropes are distant from each other.
They are located in a 3D space.
3D space. I don't know what 3D space is. Space is not 3D. Space is nothing, that which doesn't have shape. So it's irrational, the language that mathematical physicists have put into our mouths. That is, they talk about 3D space. There's no such thing as 3D space. Space is nothing.
Well, let me try your brain with an experiment here. Suppose you have 3 atoms. According to your theory, they are linked by ropes. Can you acknowledge the fact that there is a path between 2 pairs of the atom that are straight, that is from one atom to the other, and then one of these atoms, the one that is paired with 2 other atoms, he can see from his perspective, he can see a diagonal line linking the 2 other atoms. And this diagonal line is such that it can be rotated depending on the position of the 2 other atoms, such that it is orthogonal. That is, it can be rotated in one direction, another direction, and another direction, which would allow you to conclude that we live in a 3D space, even in the rope theory.
3D space. You keep saying 3D space. Space is nothing. What you have is simply 3 atoms, and they're connected by ropes. The ropes are tight. In other words, they're stretched they're under tension. Okay, and all you have, you can move that triangle of three atoms any way you want, but not because of that can you say that space has dimensions. Space does not have dimensions. Space is nothing. And people have a problem understanding that space is nothing, that it has no shape. Therefore, when you look at the moon, and you say, "What's that black stuff there?" Well, there is no stuff. The black so-called stuff is nothing. It's because if you take it to the limit, you'll find out that there is no shape the space. Otherwise, the person has to draw it and draw space for me. And then I'll know if it's three-dimensional.
But would you acknowledge that given a straight line between the two first atoms, that the third atom has essentially 360 degrees of directions that it could choose to go to or be pushed toward? Do you acknowledge this 360 degrees in one dimension and then 360 degrees in another dimension that is orthogonally to the first referred 360 degrees?
First of all, we can't say that it's not dimensions. Now see, dimension is, we have to define these terms because otherwise we get into these rabbit holes. Dimension is only the three perpendicular directions in which an object may face or point. Okay. That's different than saying coordinate, which has to do with locations, and what you're referring to, which is a vector. We have to distinguish these. Dimension, length, width, and height. Coordinates, latitude, longitude, altitude. And vectors are depth, breadth, and elevation. So when you're talking about vectors, you're talking about motion. When you're talking about coordinates, you're talking about location. When you're talking about dimensions, you're talking about facing. You're talking about the structure of an object, how it faces. In other words, it has three mutually perpendicular directions. So we can't say that we have three dimensions because an object moves. That's the first thing we need to clarify. It's mathematical physics which has screwed up the language here.
Well, that's okay. I've had enough from you here to affirm that you essentially believe that there is perpendicularity in up to three dimensions. I know you don't like the word dimension, but that's what it is. There are three levels of orthogonality in our spatial universe, and one in time.
The directions are with respect to objects, not with respect to space. You can't say that because an object can move perpendicular to another, that space has dimensions. That's where the irrationality comes into.
Well, I think that you've acknowledged as much that you are acknowledging that there is three levels of orthogonality. I'm satisfied with that.
Yeah.
If you don't want to call them dimensions, I'm fine. So let's move on. This is the realm of atoms and subatomic particles. Is this where we are at now?
Yeah, this is where Brian Greene again says that space is made of particles. And here's the quantum version. They say it's all these virtual particles that are invisible from us, untouchable, you can't approach them, but somehow they pop into our real world momentarily to make the equation of the mathematician come out right, and then they disappear immediately. He says you'll find that empty space is still far from empty, and that particles are appearing in and out of existence. And then he says they erupt out of nothingness, quickly annihilate each other, and disappear. Disappear where? Where are these? They're saying that they go back to be in space. This is what, see, they've created this monster called virtual particle. And they say, well, you're not supposed to take it literally. The particle just comes in momentarily and then goes back out. So if they need mass in an equation, they say, oh, the virtual particle just came in, gave us a little mass, and then went out. If they need charge, they say, okay, it just came in, did its thing, and then went back out. This is magic. This is not science anymore. This is saying, look, whenever we need a particle, we just pull it from the vacuum, because there's all these virtual particles that construct the vacuum. And we pull it in, we do our little magic, and then it goes back out. And see, I have an explanation. I have an explanation because I created a particle out of nothing.
Well, I'd say it's more than magic. It is the simple fact that are implied by this conservation of energy, where you can't have things pop out of nowhere unless you invoke this virtual particle mechanism. You couldn't have energy from vacuum, for example, if you don't invoke it.
Yeah, I know, because all they're trying to do is make the equations come out right, not because there's a physicality to these so-called virtual particles. Because when they need a particle, they're just going to pull a particle out of nowhere and say, we don't know where it came from. It came somewhere out from the vacuum, because the vacuum is not empty. It's made of particles. And we borrow one of these particles just so that the conservation of energy stays correct. Then it goes back out there into space. But then they tell you that space itself has energy in it, that even if you remove all the so-called visible or the tangible matter from the universe, space still is made out of particles. In other words, there's still vacuum energy out there. And so what is it? This is just ad hoc. They're just pulling particles just to make the equations come out right, not because they have a physical interpretation for how this universe works.
All right. And then here you present the way they present space. Empty space is not nothing. It's something with hidden characteristics as real as all the stuff in our everyday lives.
And the question is, what's the black stuff that gives shape to those lines? The lines are supposed to be space. I want to know what the black stuff is. He says it can bend. He's bending the lines, okay? He's twisting space. He doesn't twist the black stuff. He twists the bright stuff. And he wiggles it. He said, look, it can ripple. We have these waves of space. And you've probably heard of gravitational waves. That's what he's referring to.
I think that's probably the weakest part of physics, one that needs addressing, rather than assuming space and having our little models of particles play in that space. We should explain the phenomenon of distance.
Distance is, I define it because there are certain words you got to define for physics. And one of the first words is distance. And that's just separation between two objects. And what they've done is turn distance into distance traveled. They're talking about measurement. They're saying, look, if I unroll the measuring tape from one atom to another, that's distance. No, that's called distance traveled. I don't care about a number. I don't care about meters. I don't care about inches. I need to know physically what distance is. And distance is simply separation. That's what's this between two objects. So we have a different definition of distance than mathematical physics, because mathematical physics doesn't need the qualitative stuff. They just need the numbers.
All right. And then you comment on, according to Einstein, the secret to gravity lay in the nature of space-time.
Yeah, because he's going to do gravity with space-time. He's going to bend space-time. And again,
it was pretty successful.
Well, it's not successful. The mathematicians love it because it fulfills their needs in the mathematical world. It's got nothing to do with physics. I mean, to say that we have this entity called space-time out there, four-dimensional, unimaginable, what is that? That's religion. That's not science.
Well, we can certainly imagine a grid like this. I mean, let's leave aside the question of whether the current physics are approaching the question of space-time properly. We can definitely imagine a space-time.
No, we can't. That's Mr. Stephen Hawking tells you. Four-dimensional space-time is unimaginable, so don't even try.
I mean, I can imagine a cube, and then another cube, and then another cube, and then each of the cubes are instants. A tesseract.
No, because that's not what it is. See, when you include time, you're talking about motion. So what you're talking about is not an object. You're talking about an object moving through time. That's what, see, the so-called hypercube or hypersphere, what it is, a cube that is expanding. That's what it is. So you're talking about a picture of a movie. That's what you're talking about. That's what space-time is. That's why you can't imagine it, because you can't imagine it in a single shot. And so the way they've got around that, they say, well, you have these two nested cubes with their corners attached, right? I don't have a picture right now to show you, but you've seen the hypercube. It's a cube within a cube, and all the corners are connected. Well, what is that? That's a cube that's expanding through time. That's what space-time is. That's why they have the word time, because time is a dynamic concept. So they're putting a smile on Mona Lisa. They're saying, look, she's smiling. No, you can't have Mona Lisa smiling unless you see two frames of the movie. Then you have Mona Lisa smiling. You can't see Mona Lisa smiling with a single picture, because you don't know what smile is then.
All right. And then where does that bring us? I mean, in the end, what are you accounting for in the rope theory in terms of explaining distances or separation, as you call it?
Well, I'm just saying that all atoms, they cannot occupy the same location. And for this, you have to define location, and location is the set of distances from one atom to all the others. So if you take the distance from one atom to the other to another, and from that atom to another and to another and to another, well, the set of distances, that's the location of that atom within the universe, within all the matter in the universe. In other words, if God wants to exist, he better have distance with respect to all these atoms. Otherwise, he's not part of our universe.
Now, suppose you have two atoms bumping in the rope theory against each other. Do they repel each other because of the negative thread?
There's no negative thread. There's no negative or positive. Those are words that belong to mathematical physics. They don't belong in science. We don't use those terms negative and positive because they hide more than what they reveal. What does it mean to say that one side of a magnet is positive and the other one is negative? It just means they're opposite and they attract. That's all they're saying, but they haven't explained the physical part of that. So this stuff about negative and positive, we get rid of that altogether. We need to figure out from a physical point of view what negative and positive mean. What's happening there? What's the mechanism at the edge of a magnet, for example, right? And so the issue here is that there is no negative or positive thread. There's a single thread. The only reason we call one electron, the other one magnetic, is because when they fork out at the surface of an atom, one goes straight, the other one goes around. That's the only reason, just to distinguish that. That's the only purpose.
All right. Now, in terms of collision.
Okay. So the issue here is, first, the word distance is separation between matter, between atoms. But what does that mean? That distance is the length of a rope. That's what it is, because it's a rope that separates two atoms, and distance becomes the length of a rope. And not length in terms of meters, but whatever distance there is between two atoms, that's the length of the rope. Okay, and once you get that length is distance in that scenario, in that context, okay, then yes, you can say, well, no two atoms can occupy the same space, the same location, in other words, with respect to other atoms, and therefore all locations are unique. And if all locations are unique, what separates those two atoms is distance, in other words, the rope.
But that's what I'm wondering. Once the distance between two atoms is zero, as measured by the distance between their two electron shell, what is the mechanism that keeps one atom from driving into the other?
In fact, there isn't. There is and there ain't. They're both. Okay. Take the hydrogen atom. Okay, two hydrogen atoms. If they're rotating in the same direction, let's say they're both going clockwise from the observer's point of view, right? If they're going both clockwise, they screw into each other, and they form the figure 8 H2 molecule. If the two atoms are going in opposite directions, they come together, the rope disappears to the point where the two shells touch each other, and then they bounce away. They do not form the H2 molecule.
All right, so they can combine with each other under certain circumstances.
Yes, sir.
All right. So I'm looking at figure 8. That's space is a mystery. Jim Gates from the University of Maryland.
Yeah, and you'll see the other guy also.
It is one of the deepest mysteries in physics.
What is the deepest mysteries of the physics?
And look at number 7 as well. Number 7, put that one there because it reinforces what he just said.
We actually still don't really know.
We still don't really know.
What is space? We actually still don't really know.
Yeah, I mean, that is the question. And so that's why I think we must think of physics that could explain distance in a way that is not native to the theory.
Yeah, see, you have to think of something here, JF, and that's in 2,000 years, they still haven't been able to define the word space. They don't know what space is because they can't define the word nothing. They never defined the word nothing. So they talk about, for example, empty space. What do you mean empty space? What does empty mean? Are you removing all the trash from your trash can? Is that what empty means? I mean, if you remove all that stuff from space, what is empty space? Is it nothing? And if it's nothing, what is nothing? And they never define. They just say empty space. And it's like, oh, we all understand what they're saying. And then they tell you we don't know what space is. So they know that space is made of particles. They know that space bends. It can be twisted. It can be warped. It produces gravity. It prevents the Earth from flying out of the solar system, but they don't know what space is. Like they don't know what time is.
I think that empty space is easily understood as kind of a low pressure, such low pressure environment that nothing stays there. But I would say I agree with you that empty space is not nothing, and that there is a conflict there, because empty space has properties apparently, such as stretching by gravity, such as processing of electromagnetic waves. And so empty space is something.
Well, if it's something, it's very simple. We'll send an astronaut out there, right? He goes out of his capsule. He gets a box. He gets a piece of empty space, right? Captures it and brings it to Earth and shows us empty space down here. It shows us all the particles,
I mean,
right?
If your chest is strong enough to resist the differential of pressure, you could do that. I don't see any problem why you couldn't do that.
You think you can bring a box full of empty space?
Well, you're not going to carry some of the properties of the space because they pass through the walls of your chest, such as the gravitational curvature. But you're certainly going to be carrying some vacuum of some kind.
Look, I worked with vacuum many years, and you have these chambers. We used to put wafers in there for the semiconductor industry. What you do, you pump down the chamber. You remove all the matter from that chamber as much as you can. You really can't remove all the matter here on Earth. There's always some atoms in there, lots of atoms, in fact. And the question is, let's assume you have a perfect system, diffusion pumps, cryo pumps, whatever you need. You pump that chamber down to zero, no atoms in there. What do you have in there? Is that empty space? Or is it, if the Earth moves around, right, while you're doing that, hopefully if you're not a flat earther, you believe the Earth spins and rotates around the sun, right? So are you encountering new space as the Earth moves around the sun? Or are you carrying that same piece of space together with your vacuum chamber as the Earth goes around the sun?
Well, I think here you are playing a game where you're assuming that something must be carryable. But by your own definition of physics, things which have shape, it doesn't mean to be carryable in a chest. It can stay in place when you move the chest.
So what are you carrying then?
You are carrying a form of energy accumulated in a differential of matter pressure in the fluids that we live in.
Energy is a concept. You're taking love with you. We don't want to take love with you or information. We need a physical object.
I'm taking love with me. I have no problem with love. All right. We have Unknown Californian. He says, JF, you are looking tan, my friend. I hope you can help reconcile Red Ice and Richard Spencer, Keith Woods. Not sure why all the drama, but I believe you can be the arbiter. Yeah, I'll talk about this later, but we'll continue talking about the rope for now. Wango Tango says, any evidence of ropes from particle colliders?
First of all, evidence belongs to religion. Evidence is what the prosecutor presents to persuade, convince, recruit, convert. Evidence means that you're going to be proving to yourself, you're going to convince yourself that you believe in something. That's what evidence is. So we don't have evidence of ropes, and let me tell you why. You'll never have it. Like they've never found any. Like there's no evidence of space-time or particles or anything like that. Why? Because Mother Nature specifically made all her invisible mediators for gravity, for magnetism, for light. All these invisible, they're not only invisible, they're intangible. You can't go to the lab and say, I'm going to prove the existence of the ropes. I'm going to prove the existence of particles. I'm going to prove the existence of space-time or of space. You can't do that because all these mediators are intangible and invisible. So the see-touch criteria is what has to be discarded.
All right. Stephen Robinson says, Nassim Aramein does claim this. He has defined the shape of space. Nassim Aramein draws the shape of space. God existing outside of our universe is reasonable.
Nassim Haramein is a charlatan. That's what he is. He's the guy who's trying to include his religious beliefs within science, kind of like what the Templeton Foundation does. You know, they're trying to unite science with religion. You know, spirituality with what is it? With matter, with science, with physics. And the issue here is that Nassim Haramein talks about the interconnected universe, but he's not interconnecting them with ropes. So I don't want him later on saying, "Oh, I always said the same thing that Bill Gaede said." No way. He said something totally different. He's saying that all these things are interconnected by love, by by all these concepts that he invented. He uses the word energy, which we reject completely. His interconnected universe, interconnected by concepts, not the same thing as we have here. Here we're talking about a physical connection. We're saying there's a physical connection between any two atoms. It's a rope like entity. It looks like a rope. It looks like this. Here's my rope, okay? It looks like a rope, but it doesn't have the properties of our everyday hardware store type rope. It doesn't, you can't see or touch this thing. It just has shape of the rope. And people then say, "Oh, but if it's a rope, how do they go through each other?" They don't. In other words, they go through each other and they don't get tangled because their touch and see are not properties of this rope.
All right. Unknown Californian says, "Thanks for another great show. It's cool when you have guests on like this. Hopefully Graham Hancock will come on the show and share some interesting data." All right, we add a couple of other videos to watch. This one is NASA's Gravity Probe B project was designed to measure how much the Earth dragged space around itself.
You can see the Earth dragging space around itself. It's twirling. It's going to twirl, and it's dragging space. If space is nothing, what is it dragging? And
well, there you go, Bill. The Earth is doing exactly what you wanted me to do with a chest. It's carrying the space around. All you needed is a big mass and a rotation speed.
No, what you need is to make space into a physical object. Then you can drag it around, like you can drag water around, right? But the question is whether space is a physical object. And if it's a physical object, what is a physical object? And I'm saying it's that which has shape and not that which you can see or touch, that you can drag, right? And if it's that which has shape, the question is, what gives shape to that space? Well, what are the black stuff? That's what I want to know. Don't tell me what the lines are. Those are space. Fine, great. I'll concede it. What's the black stuff that gives shape, that gives contrast to space? That's what we need to know. Until they answer that question, they're talking nonsense. NASA.
All right. And Einstein says space and time constantly adjust by the right amount so that no matter how fast you're moving,
yeah, to keep light constant.
So do you believe that the speed of light is constant? That, at least the speed of light in a vacuum?
Yeah. Not only, no, hold it. Let's make sure you understand it. The rope model, here's the rope, right? The rope model says light is always constant, even it goes into a denser medium, or in a lighter medium, it always travels at the same speed, no matter what. Why? Because the equation of the wave equation says c, little 300,000 kilometers per second, right, is equal to frequency times wavelength. Here you have frequency. What do you have? Three. I don't know how many you can see there. I think you can see 3 links. Well, if I torque this, you'll see fewer links and they're longer. There you have. Frequency has gone down, wavelength has gone up. Now we torque it some more, okay? We torque it, and now we have more links. That means that we have more frequency, and each link is shorter. The wavelength is shorter. So the equation C equals frequency times wavelength is the equation of a rope. It has nothing to do with space or time, like Einstein said there. What does space and time have to do? See, the way they did it, they did it in reverse. They said, look, we figured out that the speed of light is constant in a vacuum, at least for them, right? And they said, well, then we have these equations, and once something has to give. And they said, well, time has to give. And they started playing around with time there, started shrinking and expanding time for the same velocity of light. That's what they did.
Now, there is an effect, I believe, that was recorded in some sort of substances, light slow down. How do you account for this?
Again, from atom to atom. So you have an atom in the air, for example, right? And you have an atom inside, I don't know, water. Water is a denser medium, right? So the question is, these two atoms, I'll put my hands together so you can see this here. You have two atoms, they're tied by a rope, right? And what happens is one atom is torquing frequency to the other atom. But one atom is in air, the other one is in this denser medium called water or molasses, if you want. I don't care. So the issue is it's sending a signal. It's stimulating that other atom, okay? And that atom is in a denser medium, and suddenly it's stimulated, but since it's in a denser medium, it doesn't pump as fast as the other one. And so what it does is it transfers that through a change in links to another atom within that same medium, within the denser medium. So from one atom to another within the denser medium, you have the same speed. All you have is a different frequency and wavelength. In other words, link length with respect to air. In air you go faster, not because you go faster, but because the number of links with respect to the link length is different than the number of links within the denser medium. That's all there is.
All right. And One Go Tango says, can we interchange the term rope with grid or matrix at times?
And I don't like grid or a matrix because rope is a physical object. Grid is not a physical object. Well, I guess you could say it's but you got to define what the grid is and what the matrix is. What are these words? These represent really concepts, not objects. We deal with objects in physics. You got to define what the object is. And until you define the object, you're dealing with energy, with charge, with field. All those are concepts. You can't use those words in science. I think
I have found a way that I could fix the whole universe for Bill Gaede. I will be traveling at the border of the universe. I will be seeding like little bean seeds, one atom after the other at equal distance. And then I will turn 90 degrees and I will seed one atom at a time at equal distance again. Then I will turn up and I will seed one atom at a time. And those will be the JF atoms. And I will ask Bill not to trust space, but trust that the JF atoms are out there and that they are interconnected through a rope that we can call an axis.
We don't trust. In science, we visualize. We have to visualize this universe. And to visualize, you need objects. And to explain mechanisms, you need objects.
All right, Bill Gaede, was there anything else you wanted to talk about before I move on to the solo part of the show?
No, that keep safe, keep your distance. Make sure you wear your mask, okay?
Bill Gaede, you, a revolutionary international man of mystery, you are listening to the government and just wearing the mask as they ask you. I'm quite disappointed.
I follow the rules because for not following the rules, I went to prison 3 years.
All right, Bill Gaede, it was a great pleasure talking to you. Bye-bye.
Yeah, we'll see you, JF. Bye-bye.
All right. What a man, this Bill Gaede. I have to say, fundamentally, I am disappointed in his refusal to define shape.